This is how the evening started, Saturday, September 21st, 1996. It was about 7 p.m. when we started session 24, which is 0 hours, 0 minutes Coordinated Universal Time. This is the Earthwatch program, which shows the position of the sun and the moon, and of course our location. And this is sky globe looking south, the moon being right here. The moon was fairly high and to the left, so with the sun setting early, we had plenty of observation time. We'd planned for two 2-hour sessions, two data tapes of 2 hours each. But as it turned out, by 10 o'clock, the sky conditions were deteriorating, and we pulled the plug on the sessions after 3 hours. This is the monster telescope, the 16-inch Dobsonian Meade. And what we do is we keep the mirror stored in a box, and the telescope tube, as you see here, stored on a 2-wheel truck in a shed. We have the STU frame and yoke for the telescope, which is covered by tarps and protected from the weather until we're ready to use it. The business end of the scope looks like, with the camera, the GBC 400 mounted on the right hand side, upper right, and the finder scope at the top, and the Dob Driver 2 hand control. It takes about 30 minutes to set this unit up. As you can see on the upper right hand part of the tube is the old Vidicon camera, which has a 117 millimeter telephoto lens. Very soon we'll be able to put the 300 millimeter lens on there, and we'll get a full version of the moon on one of the monitors rather than a golf ball size. Down in the control room we have their computer and the monitors. On the upper left we have a computer monitor, which we're not using right now, but the next monitor is the tracking monitor, which picks up a golf ball size or a slightly larger version of the moon from the tracking camera mounted on the back rear of the Dobsonian reflector. And then on the right we have two black and white monitors, monochrome monitors. One set at high contrast, low brightness, and the other one set at high brightness, low contrast. That way on the left we'll see more surface detail, and on the right, if there's anything that wouldn't show up on the left because of the brightness turned down, we can pick it up on the right. It gives us two different versions of the same image. And then down here we have a color monitor, which isn't turned on right now, but we'll give you an idea what that looks like. It gives you a false color image of the moon. Now what you'll probably notice is that using this color camcorder, that you get a false color representation of the monochrome image. This is handy in the sense that you can take a crater like Kepler or Aristarchus, and the moon will be a sort of a bluish color, and Aristarchus will be a reddish orange. But it's a false color, and it has an advantage there. Now, on the bottom here we have the beta unit. This is a front load beta machine that has pause and frame advance. The beta unit up above is used to record the tracking image. The beta unit on the bottom is the scanning image. The signal actually comes into this one first and then goes into the Panasonic VHS unit located right below this monitor. Show you the advantage of having a pause and slow tracking and frame advance. The picture that you see up above was the moon at the terminator. Now you're looking at the lunar limb, and the movement that you see on the monitor is an Earth rotational scan, where we use the Earth's rotation to scan smoothly across the lunar surface. It seems rather slow, but we're running at pretty high power, which is HPS 400 power, gets us within 600 miles of the moon. That's the apparent range. Now notice the Apennine Mountains coming in there, and I will go to slow scan or slow playback. Now on one monitor it flags a little bit. That's more an artifact of the monitor. This one flags a little bit, but as you can see, we're looking at this thing at about 3.33 frames per second. Now if we want to, we can hit the pause and hold the frame right there. We can grab that frame if we want to with our snappy frame grabber. If that particular frame that we have is blurry due to atmospherics or grabbing it at the wrong particular time, you can press the frame advance button and go the next frame. And you can do this as slow or as fast as you want to go until you get your best image to frame grab. Well, needless to say, on the night of the 21st, we didn't have the beta unit turned on. We had hoped to have clearer skies later on and then switch on the beta unit and get the better pictures. The unit that was turned on at 7 o'clock was the Panasonic, which is the one that creates the master.
0 hours, 24 minutes, coordinated universal time.
Okay, this is about 2 minutes before the event took place. Actually, a little less than that, because at 0 hours 26 minutes, that was several seconds after the event actually started. Now, we're using the Earth's rotation. We call it Earth's rotational scan to drag the camera and scope across the lunar surface. This gives us a lot smoother images than if we went into automatic computer track with the Dob Driver 2 control. You get little L-shaped movements under high power with the Dob Driver 2, and it's great for tracking, but when you want smooth images to frame grab, it's best to let the Earth's rotation take you across. We're going across the lunar surface towards the terminator. And we're less than a minute away from the event. Now the contrast can be adjusted to show more detail. We actually have two monitors set up. One for high brightness, low contrast, one for low brightness, high contrast. Okay, now we've automatically swung over to the lunar limb to let the Earth's rotation take us back again, and there's the object. We have to turn the brightness up or you can't see it very well. Okay, now we're going to go back and we're going to put it on slow motion. And when you change the brightness on the monitor, you can see lunar features. You can see a little bright spot here, which is a crater. It's caused by a raying system from that crater. And it's just about the same distance from the inside of the limb as the object is to the outside. And by watching this all the way up, we've determined that the object itself has no apparent motion. It may be moving if we really get into the nitty-gritty, but from the 13 seconds that we picked it up in the last part of the segment, actually watched it for a period of 20 seconds, but the 13-second segment that you're looking at here, it doesn't appear to have any motion. You can see it bright and dim, bright and dim. This is atmospherics, which affects the surface of the moon and anything around it. Now the distance from here to here is about 37 arc seconds. In other words, the planet Jupiter, which you see right here, is 40 arc seconds. So you can see how close this thing was. Now we've determined that if it were exactly to the right of the moon, which is would be very strange indeed, but if it was and it was at the distance of the moon, it would be about 42 miles up, in a 42-mile orbit. With an orbital satellite of the moon. We had to wait until 10 o'clock because we had planned a 4-hour session, but by 10 o'clock the sky conditions had deteriorated, so after 3 hours we were able to pull the plug on the session 24 and go down and rewind the tapes, and when we did, we found the object. So we frame grabbed it and put the image on the internet that very night on September 21st. Now the image that you're going to see here is not the same image that we put on the net, because this is actually better. The edge of the moon is a little ragged. This is due to atmospherics. Even though the images were good, that just shows you how much better it's going to be when the nights are clear and cool. And the artifact to the right, the little hourglass, that's the we will show you the actual unedited footage fed right into the VCR direct.